across AB, what is the L equivalent? We have to find across AB. Let us redraw the circuit as follows. Total current is I. Current through this is I1. Current through the second coil is I2. Let it be L1, L2. Mutual inductance is M. This is coil 1, this is coil 2. At the same time, current through this is I1, this is I2, total current is I. Only one element. Applied voltage is V. Applied voltage is V. Therefore, if you consider the loop 1, this is loop 1, this is loop 2. If you consider loop 1, algebraic sum of drop equal to 0. So, plus V minus L1 di1 by dt. Can I write like that? Why minus? Because fall in potential. Another potential is here. That potential is because of flux produced by second coil because of I2. That effect is because of M. Here also M is there. L1 and M is there. Here, if you see the dot convention, here it is entering in the dot. Here also it is entering in the dot. That's why that is also minus M d by dt of, for that flux which is responsible? I2, not I1. You will get confusion. That's why, listen. Minus L1 di1 by dt minus M. Convention is same. That's why minus M di2 by dt. Equal to 0. Or we can say that L1 di1 by dt minus M di2 by dt equal to V. This is first equation. Plus M. Second loop also I am going to take this way. I am going to take this way. This is the second loop. First loop is this. First loop is this. Second loop I am going to take following the red. For that applied voltage is V, then plus V minus L2, because inductance here is L2, di2 by dt. di2 by dt. Then mutual inductance is M. The dot convention says same direction. That's why that is also M di1. Why di1? Because the flux linked with the second coil is because of first coil, current in the first coil. That's why equal to 0. Or I can say that V equal to L2 or M di1 by dt plus L2 di2 by dt. Let it be second equation. Find by Maxwell's equation, we can find di1 by dt and di2 by dt. So how to find that? First, let us assume that this is di1 by dt can be called as I1 dash. I1 dash is derivative of I1. No. So for convenience, let us write this equation as L1 I1 dash plus M I2 dash equal to V. This is first equation. Here V equal to M I1 dash plus L2 I2 dash. This is second equation. So if you put these two in matrix form, what you will get? If you put these two together in matrix form, what you will get is L1 M L2 I1 dash I2 dash equal to V. Am I correct or not? You will get yes. Now we can find I1 dash. I1 dash equal to what? I1 dash equal to, we have to replace this first column by this. First column by this. We have to replace this. So we have to replace this by this and find I1 dash. Determinant of V M L2 upon L1 M L2. What is I1 dash? Find I1 dash. I2 dash equal determinant of L1 M V divided by determinant of L1 M L2. That is equal to what? L1 minus M divided by L1 L2 minus M square. Total change in current. That is, I found another circuit that has only one coil. Current through this is equal to di by dt. That current is equal to di1 by dt plus di2 by dt. I found another circuit, equivalent circuit. Its change in current is equal to change in I1 plus change in I2. I found that is L equivalent. That is L equivalent. That's why I had to add these two together. If I add these two together to find di by dt, that is I dash equal to I1 dash plus I2 dash. That is equal to what you will get? L1 L2 minus M square. Let it be 3, let it be 4. Adding 3 and 4, because denominator is common, that's why you will get V. What you will get? L1 minus M plus L2 minus M. That is equal to V L1 plus L2 minus 2M upon L1 L2 minus M square. Let it be 1. Let it be 5. From fifth equation, we can say that V equal to, from the fifth equation, we can say that V equal to L1 L2 minus M square divided by L1 plus L2 minus 2M multiplied by di by dt. Let it be sixth equation. Am I correct or not? I am keeping V on the right hand side. I bring all these things to the left hand side. So V equal to L1 L2 minus M square divided by L1 plus L2 minus 2M. Can I say like that? That is V. This is the equivalent circuit. This is the equivalent circuit. For that, V equal to what? V equal to L equivalent di by dt. This is seventh equation. Comparing sixth and seventh, L equivalent equal to L1 L2 minus M square divided by L1 plus L2 minus 2M. In the same way, we can prove for if a dot is in the opposite direction. The applied voltage is V. Applied voltage is V. Applied voltage is V. This is L1, L2. It has a mutual inductance M. Current through this is I1. Current through this is I2. Here it is entering the dot. Here it is leaving the dot. That's why the first equation, if you write for this loop, what you will get? V plus V minus L1 di1 by dt minus, but here current is entering the dot, here leaving the dot. That's why another minus M di2 by dt equal to 0. This minus sign is because of potential drop, for that we are writing. But this voltage induced in the same coil 1, because of I2, opposes the first voltage. That's why 2 minus sign, that's why it becomes plus. Therefore, V equal to L1 I1 dash minus M I2 dash. That is first equation. Similarly, we can write for this part, you can write one more equation. That is KVL plus V minus L2 di2 by dt minus, because of same minus we have to put, same minus here also, minus another minus, because the dot is here, current is entering, here it is leaving, that's why another minus sign. M, this is because of first current, first coil current, that's why equal to 0. Or you can write V equal to M minus M I1 dash plus L2 I2 dash. This is second equation. Find I1 dash and I2 dash by using Maxwell's equation. If you put this in matrix form, you will get first equation is L minus M L2 I1 dash I2 dash equal to VV. So find I1 dash I2 dash by using Maxwell's equation. I1 dash equal to determinant of VV minus M L2 upon L1 minus M L2. That is equal to L1 L2. You will get the same minus M square. But here V times L2 plus V times M, that is equal to V times L2 plus M divided by L1 L2 minus M square. Let it be third equation. Similarly, I2 dash equal to determinant of L1 minus M VV whole divided by L1 minus M L2. That is equal to L1 L2 minus M square V times L1 plus M. Let it be fourth equation. From 3 and 4, we can say that I1 dash plus I2 dash equal to denominator same L1 L2 minus M square. That's why if you add these two together, you will get L1 plus L2 plus 2M. You will get. That is fifth equation. That is equal to I1 dash plus I2 dash. If you consider the equivalent circuit, that is equal to di by dt. That is equal to di by dt. This is I equal. This is I1, I2. We know that I equal to I1 plus I2 means di by dt equal to what? di1 by dt plus di2 by dt. By using that, we wrote di by dt equal to this. From this, we can find V. V equal to what? V equal to L1, L2 minus M square divided by L1 plus L2 plus 2M multiplied by di by dt. Let it be sixth equation. L1 V equal to L1 L2 minus M square divided by L1 plus L2 plus 2M multiplied by di by dt. Sixth equation. If you consider an equivalent circuit, I am going to consider. An equivalent circuit is considered here. It has only one coil. That is L equivalent. Applied voltage is V. Therefore, V equal to, I can say that L equivalent di by dt. The same effect that gives the seventh equation. Comparing sixth and seventh, L equivalent equal to, comparing sixth and seventh, L equivalent equal to L1, L2 minus M square divided by L1 plus L2 plus 2M.